Hello, and welcome to the ongoing COPE presentation series focused on improving the addiction medicine curriculum in medical school education. This series is particularly focused on how the subject of addiction medicine can better be embedded in standard clinical rotations. This presentation by Dr. Sharon Levy will address the area of pediatrics. Dr. Levy is a professor of pediatrics at Harvard Medical School. She is the chief of the Division of Addiction Medicine at Boston Children's Hospital, past chair of the American Academy of Pediatrics Committee on Substance Use and Prevention. She's the past president of AMERSA, the Association of Multidisciplinary Education and Research in Substance Use and Addiction. She serves on the board of directors of the American College of Academic Addiction Medicine, ACAM. She has a long history of assisting adolescents with substance use disorders, and she has written extensively on the topic. She established the nation's first accredited addiction medicine fellowship focused on pediatrics at Boston Children's Hospital. She's done a great deal of work on identifying and addressing adolescent substance use disorders in general medical settings and pediatric primary care. And I welcome Dr. Levy.
Thank you for that wonderful introduction. And I want to thank the audience for spending some time today thinking about pediatric addiction medicine. Today, I'd like to talk about the impact of substance use on the developing adolescent brain. So I'm starting with a rather old slide that shows us the brain weight by age. So on the x-axis, you can see the weight. On the y-axis, you can see the individual's age. And I've highlighted age 10 to 12 because that is the age at which the brain by weight reaches its adult size. And for a very long time, adolescence was not recognized as a unique developmental stage. In fact, it was really recognized with the baby boom generation when they started growing up and becoming teenagers, probably because this was the first group of adolescents who had disposable income and they became kind of a market share. And so there was a lot of interest in understanding what their interests might be. Now, to me, that's a rather remarkable statement because these pictures I've taken off of Google Image just by typing in the word adolescent and seeing what comes up on the first page. I made a little collage. And if you sit back and look at this collage, you can really start to think that adolescents they look a little bit different than adults. There's something really different. And the fact that we didn't recognize them until this adolescence as a unique stage until very recently is really interesting. It seems like we really missed a lot. But today, we really understand that it's not just that adolescents are younger than adults, but it's also that their brain is still developing, and there are facets of their brain development that really account for a lot of the things that we think about with the adolescent stage of development. So here I'm showing a slide that's demonstrating what the brain looks like at different ages. So on the left, we see a brain of a newborn, and what you see is that there are few neurons and few connections between them. So there's really a lot of room for growth. In the middle panel, we're looking at a 6-year-old, and we can see here that the number of cells has increased very dramatically, and perhaps even more dramatically are the number of interconnections between them. And then as we move from 6 years to 14 years old on the right, we actually see a decrease in the number of connections. So the brain tissue actually looks a little bit more sparse. Think about why would that be? Why would it be good to get rid of brain tissue? Well, it turns out that as brains grow, the connections that are not used, you develop a lot of connections early on, and that really configures the brain for learning new information, right? So this is why we think of children as excellent learners. This is the time in life to learn a language. It's the time when you might learn to play an instrument. It's, in fact, there's a whole industry that's developed on teaching skills to young children because their brains are sponges that can absorb things rather quickly. But what happens after in the next stage is that as we remove some of the smaller unused connections between neurons, and the connections that remain grow larger and get wrapped in fatty myelin tissue, which makes the speed of conduction much faster. So while the brain of a 6-year-old might be perfectly configured for learning, it's really an older brain that's better configured for proficiency. And this pattern of development happens in different parts of the brain at different ages. I'm showing an old slide here that shows mature brain in blue and maturing brain, or immature but maturing brain, in different shades of greens and reds. And what you can see is that there's a very orderly march. It's generally from the back of the brain to the front, and happens in roughly it happens in the same parts of the brain at roughly the same ages, always in the same order, roughly the same ages. And what I also want to point out is that even at 20 years old, which is the end of this graph, you could still see that there's still a fair amount of immature brain in the frontal cortexes. And this process is thought to complete somewhere in the mid-20s for most people. So I am trained in developmental behavioral pediatrics and was very interested early on in my career what this brain development looks like in terms of understanding the behaviors of children at different developmental stages. So in the first, early on, in the first couple of years of life, there's a lot of brain development happening in the cerebellum, that part of the brain all the way in the back. That is, of course, responsible for fine motor, gross motor coordination. And what we see in these first couple of years is that children are really driven to stand up and take their first few steps. And so much so that we call this developmental stage toddlerhood, right? And you can imagine in your mind's eye a developmental feedback loop, right? Where a child gets old enough, big enough, strong enough to actually stand up. And the act of standing is actually sending feedback to the cerebellum that's giving the child the opportunity to develop more skills, including walking, which goes from that wide-based kind of awkward gait of early toddlerhood into the more refined adult-looking gait by the end of that developmental period. As we move to the preschool years, there's a lot of development occurring in the amygdala, which is part of the brain that plays a big role in emotional response, emotional regulation. We know that this is the age that children are prone to have tantrums, right? Sometimes in pediatrics, we call this the terrible twos, when children will have tantrums that kind of come out of nowhere and they disappear out of nowhere, with the adults in the room all kind of watching it and wondering what happened. And this is all going on as that amygdala is maturing. In the school age years, the nucleus accumbens, which is the seat of the reward center of the brain, is undergoing very rapid development. And it's during this time in development that we expect children to become self-motivated, to start figuring out what they like, what's exciting to them, and develop their own interests. And that's very correlated with this particular phase of development. And then the last part of the brain to develop, known as the prefrontal cortex, happens during the adolescent years. And the prefrontal cortex is responsible for what we think of as executive functions, things like self-monitoring, impulse control, that sort of thing. And that's the last part of the brain to develop, and that doesn't happen until sometime in the mid-20s, which means that adolescents, it's not that they can't make good decisions, but they tend to make they're not reliably making good decisions, right? They're often making impulsive or rash decisions and not thinking everything through. So in the model that I've just demonstrated, we can consider adolescence the time period after the nucleus accumbens, or that that reward center is completely mature, right? You can think of that as the gas pedal of behavior, but the prefrontal cortex that's really working on error monitoring and self-correction and impulse control and those sorts of things, could think of as the brake pedal of the brain, is still maturing. Adolescence is that strip right in there. And this normal developmental imbalance accounts for the kinds of tropes that we expect to see during adolescence. So here's a slide that shows this well. In this experiment, researchers brought participants into a lab and they recorded their brain receiving a reward. And there were a couple of conditions. The first condition was that they received a small reward. The second was they received a larger reward. And there were participants of different ages. So in the green bar, we're looking at what happens in the adult brain. And what you can see is if you compare the small reward on the left, you see a small bump when adult participants received a small reward. And if you look over on the right, you see a large bump when they received a large reward. Something you might expect, that the size of the amount of firing in the reward center was roughly proportional to the reward size. If you look at young children, it's a little bit of a different story. They're in light blue, and you can see that whether they received a small reward or a large reward, they had roughly the same amount of dopamine firing in their reward center. This is why pediatricians will often give out stickers in their practices as rewards for young children, because it turns out, from a neurological point of view, stickers work as well as any other larger reward. Now, look at the black line, which represents adolescence, and what you see is really striking. So for small rewards, adolescents actually, they deactivated their reward center below baseline firing. So that's like saying that receiving a small reward was an unpleasant experience for adolescent participants. But now look over on the right, we look at the large reward, you could see that the adolescent brain fires much more strongly than either the adult or child brain. And that's what's really driving behavior in this age range. And when we understand it this way, we can really understand the impact of substance use and why substance use is so attractive at this age group. Because the final common pathway, or the reason that people enjoy substance use, is because substances are directly causing firing of dopamine in the pleasure and reward center. And so what that means is that it's a very effective and efficient, albeit unhealthy, way to satisfy the developmental drive to look for activities that will result in a lot of dopamine firing. And we know that because of this, most drug use starts in adolescence. Given what we know about development, it's completely predictable that the group of individuals who are going to be most interested in substance use are going to be adolescents and young adults. And here we have a graph. This is from produced by SAMHSA in 2024, and we're looking at the age of first use before age 21 in gray versus after age 21 in blue. And what we can see for alcohol, nearly 75% of people who initiate alcohol use will do so before their 21st birthday. More than 50% of people who use cannabis. Now, here I'm showing nicotine vaping on the right, and it's interesting that it's a little less than half of people who initiate during their adolescence. And that has to do with, that's been changing over time. Certainly when we look at cigarette smoking, almost all initiation was happening before age 21, but the social context around these substances is also important. So not only are adolescents going to be the part of the population that would be predictably most interested in using psychoactive substances, but because of brain development, they're also developmentally most vulnerable to developing substance use disorders. And here's just an analogy. We can think of those prefrontal cortexes as actually protective of the reward center. And so the inhibitory signals that come from that part of the brain protects the brain against the changes that are associated with substance use disorders that are actually happening in the reward center. During adolescence, those frontal lobes are not yet fully developed, and so they're not able to provide as much protection as the adult brain. And this is some empiric data looking at age of first use and later risk of a substance use disorder. And you can see for both alcohol and cannabis, the risk decreases over time. Kids who report their first drink before age 13 have nearly 50% chance of ultimately being diagnosed with an alcohol use disorder. And that risk falls down to less than 10% for those who start drinking after age 21. Now I'm going to shift focus a little bit and talk about individual substances, and I am going to start with nicotine. And these are chemical drawings of acetylcholine on the left, which is, of course, the neurotransmitter that's made by the human body. Nicotine on the right, which is a chemical made by plants that is actually toxic and protects plants against insect infestations. Nicotine can bind to acetylcholine receptors, particularly in the central nervous system, where they bind to the cholinergic type of acetylcholine receptors. They do not bind, where they bind to the nicotinic receptors primarily in the central nervous system. Here is a diagram of what happens to nicotine receptors in the central nervous system when someone smokes. So you can see on the left, we have a non-smoker. On the right, we have somebody who's just started smoking, and you can see that the hollow circles represent acetylcholine. That's the natural neurotransmitter, and the black circles represent nicotine, which are mimicking acetylcholine and binding to those receptors. And over time, what happens is that the neurons downregulate, so there are fewer acetylcholine receptors present on that neuron. And so this is an unusual pattern. And for opioids and other substances, we sometimes see upregulation of the receptors. But either way, the change in receptor pattern actually results in tolerance, meaning that more substance is going to be required to get the same effect, and also the withdrawal symptoms if somebody stops using abruptly. This happens, the nicotine binding is very efficient in the central nervous system. This is a graph of a scan of somebody who's actually smoking a cigarette, and what we see on top is brain at rest. On the bottom is brain of somebody who's smoking a cigarette. A cigarette is about 10 puffs. So 0.1 puff, 0.1 is 1 puff of a cigarette. And as we see, by the time you get to about 0.3 puffs, most of the receptors are saturated. And then by 3 complete cigarettes, you see that the brain is completely saturated. And this is a slide just to remind us of the dopamine projections in the brain related to nicotine. So you can see that nicotine is going to cause dopamine firing in the nucleus accumbens. It's labeled on this graphic. This is just a reminder that there are also projections from the nucleus accumbens to the prefrontal cortex. And so nicotine, like other substances, is having an impact on our prefrontal cortex and our decision making. Nicotine is a very interesting chemical because it releases so many neurotransmitters. So of course it releases dopamine. That's what accounts for the buzz that people experience when they use nicotine. It also releases acetylcholine, right, which is the major neurotransmitter of the parasympathetic nervous system, right? So it helps actually people calm down and focus. It also releases norepinephrine, which is a major neurotransmitter of the sympathetic nervous system, and it can be part of the fight or flight reflex. It releases serotonin, which is what sometimes called one of the happy hormones. It's important in mood management, and as we know, important as a target for antidepressants. It impacts glutamate and GABA, which are the major inhibitory neurotransmitters in the central nervous system. And it hits the endorphin system as well, which is, of course, important for pain relief. Nearly every major neurologic system is hit by nicotine. And the impacts are different on adolescents versus adults. Here showing you the difference in experience between adolescents and adults. And what we see is that kids are generally more sensitive to the rewarding effects of nicotine. They're less sensitive to withdrawal, and they tolerate high doses of nicotine much better. And that's really important because it impacts the different nicotine devices that are available. This is a quote from a 14-year-old boy who I had seen in the clinic. This is a quote from quite a long time ago, and he was coming into the clinic shortly after the release of Juul. He had started using it. His parents became concerned and brought him into the substance use disorders program. And this is a verbatim quote. He said, "When I first used, I would get a buzz and my entire body would feel tingly. My eyes would water up. I would feel as if I had been spinning around and just stopped." And when I heard that quote, I thought he was telling me why he wanted to quit. It sounded like an unpleasant experience to me. But then he added, "It felt great." And that is the difference between a young brain and an older brain in what feels good. And then he continued to say, "I don't feel those things anymore." And that, of course, was describing that he had developed tolerance. So we want to spend just a couple of minutes talking about e-cigarettes or vapes, because this is far and away the most common form of nicotine consumption for young people. This is a figure of a vape showing the basic parts, and all of them have a mouthpiece. They all have a tank that will hold liquid, sometimes called e-juice, that'll have nicotine. It could have cannabis in it. It could have both. It's got a heating element so that when the device is turned on, heating element gets hot, turns the liquid into actually what some people call a vape, but would be more chemically accurately called an aerosol, because it's a gas with solids, carrying solids that are dissolved in the gas. Some of the older devices will have a switch that turns on the heating element. And then, of course, there's a battery to power the system. This is showing you an old version that some of them put a red light on the end to make it look a little bit more like a cigarette. And so what happens is, as the liquid is heated, it turns to gas, and there are lots of chemical reactions occur within that tank as the heat is added. And so you put a few chemicals in, you get a lot of different products out. Because all of the e-liquids are proprietary, we don't always know what's in them unless somebody has reverse engineered them. But people have looked at common products that come out of the reaction, and there are a few listed on this slide. They're often in low doses, but you can see they're fairly toxic chemicals. So when the vapes first came out, or the e-cigarettes first came out, they were marketed as an aid for smokers who want to reduce their exposure to the toxic products of combustion. But a few years after the initial e-cigarettes came out, we had, of course, these new products that are attractive to young people come out in the 20 teens. And of course, Juul was the one that really led the way. There were a couple of really important innovations that made these newer products possible. And the first was the innovation to nicotine itself. So nicotine, which is available mostly as a free base in cigarette smoke and in the first few iterations of e-cigarettes, turns out that it's very irritating to airways. People can develop tolerance, smokers develop tolerance to this, but it's something that new smokers often have trouble with. And it really prevented the concentration, kept the concentration of nicotine fairly low in the early vapes. Then there was some experimenting with nicotine salts, which are actually less harsh than the freebase, that allowed manufacturers to increase the concentration of nicotine in the e-juice. Of course, we all know this story. The Juul company led the way, but many manufacturers put out all kinds of fruit, mint, and dessert flavors that are very attractive to young people. And there were some important innovations to the device. So Juul in particular was sleek. It's something that was easily concealed, looked like it could be a thumb drive or an office product. They put in what they call Easter eggs, which are little designs or what they call party lights that you really had to play with the device a lot to know. They also made some changes under the hood. They put in a chip, so that allowed them to eliminate the on-off button. That means that these devices can actually detect when they're being taken out of a pocket and lifted up to the mouth. And so the heating starts before the device ever reaches your mouth. And so it's really ready to go as soon as it gets there, making it somewhat easier to use. They also added some high resistance coils that made the heating process much faster. And all of these changes together allowed the Juul company to deliver nicotine in higher concentration and much quicker than other products. And this is a graph that actually comes from the Juul company marketing materials themselves. But this is really important because remember that it's really the people who will enjoy this higher, faster dose of nicotine are either people who have already developed tolerance, so this is like people who use nicotine for a long time, or young people who can tolerate that, who really enjoy that buzz, much more than older people will. And of course, the principles of addiction medicine are the higher the concentration and the faster you can get it to the brain, the more addictive the pattern will be. So back in the mid 2015s or mid 2010s, what we started seeing was kids playing with these products, starting to use these products. We saw what was ultimately just called an epidemic of youth use. Kids would play with them. They would do tricks with them. We started hearing all kinds of words that we had not heard before, including being Nick sick, which actually was referring to headache, vomiting, all of these symptoms, which are actually mild symptoms of nicotine toxicity, really representing how high a concentration these kids could get out of these devices. And of course, we saw this tremendous spike of high school student tobacco product use. This is showing from 2011 to 2018. I've circled the e-cigarettes. You can see that black bar is 2018. We really saw use of these products shoot up. And so where are we now? This is an updated slide looking at past 30-day prevalence, often considered current use in 8th, 10th, and 12th grade, and it goes all the way out to 2024. And you can see overall rates peaked somewhere around 2020, and then during the pandemic, they started coming down and have started to stabilize around the rates you see here. So it's good news that high school students have reduced their rates of use of e-cigarettes really rather dramatically since the pandemic. On the other hand, according to the National Youth Tobacco Survey, still more than 2 million kids currently use e-cigarettes, meaning in the past 30 days. More than 1 in 4 kids who currently use e-cigarettes use them daily or more. So these are heavy users. And 9 out of 10 still use flavored e-cigarettes. This is just some of the flavors that you can get easily, right? And, as you can see, many of these flavors are not particularly targeting adult users. Things like tangerine ice, banana ice, one would question who that's being marketed towards. And there's been another change since Juul left the scene as well, and that's been the amount of nicotine that's contained in these products has grown dramatically by providing larger tanks in these disposable devices. So Juul pods had less than a millimeter, just 3/4 of a millimeter of e-juice in them, and that correlated with about 40 milligrams of nicotine, which was approximately the same amount of nicotine you could get out of 1 pack of cigarettes. Now, over time, draw your eye to the bottom. Geek Bar are these, now we have these chunky disposable e-cigarettes, some of them hitting as many as 16 milliliters, quite an expansion of the amount of fluid that's in these products, which correlates to about 20 packs of cigarettes, all stuffed into one device. This is important because unlike cigarettes, vaping, there's no stop signal to vaping, right? So with a cigarette, you light it up, you smoke it, you take your 10 puffs, and you're at the end. You have to put it out and stop or light another one. With these bigger products, you don't have to stop. There's no signal to stop until you go through the entire volume of e-fluid. 16 milliliters is quite a lot, or your battery goes dead. So you can really go for a long time and use a lot of nicotine. And what we saw about 1 year ago in our clinical program is that we saw a very sudden rise in the amount of cotinine, which is metabolite of nicotine excreted by the patients who are in treatment in our substance use disorders program. We saw a very abrupt increase starting in about October 2024. And the cause of that increase is not completely clear, but we're very suspicious that if you take the manufacturers are now adding tasteless and odorless anesthetic chemicals to these products that are allowing people to use more and longer. There have been some publications, some products, including WS3, which is not detected as a flavor in these products, is being added to these large volumes, allowing people to go through very large amounts of nicotine and resulting in these very high levels. And then I'm just going to finish with the talk on nicotine with a case, a young patient named Jack, who just really illustrating the issues around nicotine. So some people consider nicotine addiction as a nuisance disorder because it keeps people smoking, and we know smoking is bad for health. But in fact, nicotine addiction is a serious condition in and of itself that's really distracting to young people, that actually changes lives. So this is Jack. He first, again, this is an older case. He came into the clinic in the 20 teens. When he was 14 years old, he reported that he started using Juul at age 13. He was caught by his parents after a couple of months. Addiction had probably already developed. His parents forced him to quit. He did okay. But in the fall, when he went back to school, he restarted. And he told me all he could think of is about nicotine. He said he didn't feel right since he quit, that he would zone out. He actually decided to quit playing sports because he would sometimes zone out in places where he thought it might be dangerous, including the football field. He met criteria for severe nicotine use disorder. He had no other substance use, which was confirmed through drug testing, and no mental health disorders. So this was really the effects of nicotine addiction, just underscoring that this is really important condition for young people. And with that, I want to move on, say a few words about cannabis. So here I'm showing you a molecule of THC, which is the active ingredient in cannabis, which is, and of course, it's a molecule that's made by the cannabis plant. On the right is anandamide, which is the neurotransmitter made by the human body. THC can actually bind to the cannabinoid receptors, which are really where anandamide would normally bind. This is a diagram showing us the parts of the brain that are very rich in cannabinoid receptors. Right in the middle where it's glowing purple, that is the nucleus accumbens, right? That's the pleasure and reward center. And of course, THC can trigger dopamine release, which makes use pleasurable. There are other parts of the brain rich in cannabinoid receptors, including the frontal cortexes, again, responsible for executive functioning. And so cannabis use will impact our functioning and decision making. The cerebellum, way in the back, is rich in cannabinoid receptors, and that is the part of the brain responsible for gross motor coordination. So we can surmise from this that cannabis will impact our coordination. And then the hippocampus right in the middle is responsible for learning and memory, and that is also rich in cannabinoid receptors. So when either anandamide or THC bind to the cannabinoid receptor, it quiets the cell down, so it stops release of neurotransmitters into the synapse. So it's quieting cells down. And it turns out that delta-9 THC, again, the active ingredient in the cannabis plant, is more potent, about twice as potent as anandamide, which means it will outcompete, but it will also stay on that receptor longer than anandamide normally would. Why is this important? Because during adolescence, we know that it's really important that cells that are not signaling as much are going to be pruned away. And so we want that pruning to be happening with a surgical scalpel and not a blunt instrument. And this is a slide showing us that cannabis users, people who use cannabis during their adolescence, have on average smaller hippocampuses. So if you look at on the left in red, we see controls with no history of cannabis use. And then if you look in the green, sort of in the middle there, these are people who were using straight THC or products that were very high in THC. And what we see is a statistically significant difference in the size of the hippocampus. What's also important is on the right, it looks like the people who quit, it looks like there's some normalization. Why is this important? Well, it's also been shown that people who use cannabis during their adolescence have a drop in their IQ compared to, so IQ is thought to be stable trait. If you look at people who are non-cannabis users, their childhood IQ and their adult IQ is stable. If you look all the way on the right, long-term users, we're seeing a decrease in IQ of about 6 points over 20 years. These are people who are using cannabis very heavily in their adolescence. Now, these are correlations, and so it's impossible to say just from this data that cannabis is causing these IQ drops. But they're important associations, they're important things for us to think about and watch out for. And it's also important to understand this in the context of what else we know, including the morphological changes that are associated with cannabis use. And this is a publication from 2021 looking at the rate of psychotic disorders among people who used cannabis during their adolescence, and it was a meta-analysis that found when you combine all the data, the risk of a psychotic disorder increases roughly 2.5 times in people who've used cannabis during their adolescence compared to those who didn't. This is data from our own group. So we gave surveys to kids who were coming into the adolescent medicine clinic for routine primary care. These were not patients coming into a substance use disorders program. They were just coming in for primary care. We asked them if they had used cannabis in the past year. About a third of them said they had. And of those who reported cannabis use, we asked them if they had experienced hallucinations, paranoia or anxiety associated with their cannabis use. And you can see the numbers were very high. More than a quarter said that they had hallucinated. More than a third said that they experienced paranoia or anxiety. And when we put these two together, more than 40% said that they had experienced one of these symptoms. Now, and again, these are not people who are coming in for mental health or substance use disorder treatment. They're really coming in for primary care, and they're not likely to be asked these questions. So in most of these people, presumably the symptoms resolved, but it's just a marker to us that something really important is happening in the adolescent brain when it's exposed to THC. Finally, I will move on to talking about alcohol. This is a molecule of alcohol shown here, and here it is compared with GABA. Now, alcohol is a small molecule. It looks a lot like water, which means it has a lot of targets in cells, outside of cells, really all over the body. But its main target is the GABA receptor. Which is the same target as GABA, of course, but also benzodiazepines and barbiturates. So it's a common target for sedatives, although all of them have unique binding sites. This is a diagram just showing us the projections of alcohol on the brain. So, of course, there's dopamine firing in the nucleus accumbens with alcohol use. That's what makes it pleasurable. There are projections from there to the amygdala, which is responsible for emotional regulation. There are also projections to the prefrontal cortex, responsible for executive functioning. So there's a lot of the similar projections with all of these substances. Interestingly, alcohol has different impacts on people of different ages, just like nicotine and cannabis do. And in particular, alcohol suppresses motor response in adults, but activates people motorically, younger people motorically. So this is a really striking difference, and this was shown with adolescent rats, just to kind of explain the concept here. So if you put rats in water, they don't like swimming, and so they'll swim to a platform as quickly as they can. If you give rats alcohol before you put them in the water, what you'll see is that for adults, their swimming speed is decreased, and so it takes them longer to find the platform. So they're motorically depressed. If you look at adolescent rats, it turns out that their swimming speed is unchanged when they're intoxicated with alcohol. So they're still moving at the same rate, but their time to find the platform is still increased because they're not swimming efficiently. They can't remember where they're going. This is just a reminder that the pattern of alcohol consumption we see that's most common in young people is sporadic heavy drinking, sometimes called binge drinking. And the National Institute on Alcoholism and Alcohol Abuse estimates that about 90% of all alcohol consumed by underage drinkers is occurring in the context of a binge, which is why alcohol consumption is so dangerous for this age group. And this is a slide just reminding us that the risk of a car accident increases with blood alcohol concentration for all age groups, but the slope is much steeper for young people. So you look at those top bars where the slope really takes off, and that is young males on the top, and then young females right underneath them. So to pull this all together, the points I hope I've made clear for you in today's presentation is that adolescent development primes teens for substance use. It solves a developmental drive for them, although in an unhealthy fashion. That all psychoactive substance use triggers dopamine release. That's the final common pathway that makes psychoactive substance use feel good for people. But without the protection of mature frontal cortexes, adolescents are at greater risk for the neurological changes that are associated with substance use disorders and addiction. Of course, substances each have their unique impacts on areas of the brain, leading to the unique clinical picture that results from long-term use. But even harm reduction strategies such as e-cigarettes, which came out and were advertised for addictive smokers to reduce their risk, have negative consequences on adolescents. So it's a completely different consideration. So we need to consider the impacts on this age group when we're thinking about policy and to balance benefits to adults with harms to younger people. So with that, I will stop there and thank everybody for their attention. If this piqued your interest and you'd like to know more, in particular, if I've convinced you that there are some really significant problems resulting from adolescent substance use and you'd like to know what to do about it, I would encourage you to take a look at the Handbook of Pediatric Addiction Medicine, which is published by the American Academy of Pediatrics Publishing House and can be found at the QR code on the right. And there's also a talk for parents on Audible called How to Talk to Your Kids About Drugs and Alcohol, QR code on the bottom there. Thank you very much for your time and attention.
Thank you, Dr. Levy. That was very informative, and I think, goes a long way and would go a long way in helping medical students and really all physicians to understand the impact of substance use on adolescents, and then in many ways it really is a pediatric illness that so many young people, if they get started in the young years, their chances of developing a real substance use disorder increases significantly. So thanks again, and we appreciate this. This presentation will be available. It's going to be sent out to many of you directly, and then it will be available on the COPE website. So again, thank you.
Thank you.